The Hubble Space Telescope has given us this amazing new image of deep space. So when you look at this image, you're seeing hundreds, possibly thousands of galaxies. Each of these galaxies can contain billions of stars and perhaps their planetary systems. So it's quite mind-blowing what we're seeing here. We're calling this a frontier field because it's helping us push the frontiers of what we understand in astrophysics about the universe. This is an image of a cluster of galaxies. There's so much mass in this cluster from the galaxies and from the dark matter that we don't actually see that it can actually distort space itself. This is a phenomenon that Albert Einstein predicted. And in this case, light traveling through this distorted space will itself get distorted and magnified. What that means is in this image, we can actually see distant galaxies behind the foreground cluster of galaxies. And the light from those distant galaxies is getting warped. You can see kind of funny looking arcs in this image and also magnified. That's helping us understand the dark matter in this foreground cluster that we can't see itself. But it's also helping us to understand these very distant galaxies that are being magnified by this effect. Galaxies so far in space and time that we wouldn't be able to see them well without gravitational lensing. Well, the Hubble Space Telescope is helping us understand the universe very distant and the universe very close. So it's helping us understand these very distant galaxies, such as the frontier fields are showing us, but it's also helping us understand in our own galaxy these nurseries where stars and planetary systems are formed. We're looking at these beautiful nebulae that are signposts of recent star formation. We're studying regions around stars where planets are forming. And we're even analyzing the atmospheres of planets outside our solar system. We just recently released a new analysis of the atmospheres of two of these exoplanets from Earth-sized planets that are in a system only 39 light years away. That's very close by in cosmic terms. Oh, Hubble has seen so many fantastic phenomena and objects in space. It's hard to know where to begin, but I think the most interesting features we've seen are with galaxies. We've seen that galaxies can actually merge together and create tidal forces that spur new star formation in those galaxies. We've actually learned that the cores of galaxies can contain supermassive black holes. These beasts are pulling in a lot of matter, but they also can foster the expelling of these high velocity jets that can move out almost as fast as the speed of light. We're also finding phenomena that span the whole range of the universe. We found with Hubble and with ground-based telescopes working together with Hubble that the universe is not only expanding, but that expansion is actually getting faster. It's accelerating, pushed apart by something we're calling dark energy as we study more and try to understand what that actually is. These unexpected discoveries with Hubble keep us freshly excited about what's yet to discover in the universe. And so Hubble is continuing in a very healthy and active mode to discover new things in the universe that we've never expected before. Star Trek and other similar science fiction TV shows and films, I think, inspired me to be curious about the universe. I wanted to explore myself and go see those strange new worlds. I wanted to learn about moons around other planets. I wanted to learn about other star systems. So I think science fiction, like Star Trek, inspires curiosity and wonder and a sense of awe in the universe. And science is a wonderful tool for exploring the wonders of nature. So I think that's why I ultimately became a scientist, an astronomer, because of that curiosity that was fertilized by Star Trek and other very interesting science fiction and science fact that I learned about from a young age. Well, these deep fields of space, like the frontier fields, are phenomenal because they show us that galaxies fill the universe. So in fact, if we pointed the telescope in any direction and collected light for quite a long time, we would see another collection of galaxies just like this Now, the frontier fields are unique because we have pointed them specifically at regions where there are clusters of galaxies. So there's quite a few galaxies that are held near each other by their mutual gravity. We did that on purpose because we wanted to study those clusters, and we wanted to study this phenomenon called gravitational lensing, where all the mass in this cluster, including the dark matter we can't actually see, will distort space and will actually magnify light from even more distant galaxies. Well, the Hubble telescope has a wonderful gallery of images that's free and available to everyone on our website, which is nasa.gov/Hubble. You can also find us on Twitter at NASA_Hubble. And you'll see on these sites and on Twitter that we have a new campaign called Spot Hubble. This is a campaign to help all of us spot images of Hubble or images from the Hubble telescope in culture all around us. The Hubble Space Telescope has inspired people all around the world through these iconic images, and we see them everywhere around us. So here's a place we can gather those iconic images and enjoy what the Hubble Space Telescope is providing for us in terms of exploring the universe.